We are looking at complements and union of events. So compute the probability of the complement of an event. If E is the event, then, so this is what the complement looks like. It's E, like they call it like E prime. It's E with an apostrophe. So the probability of E complement is equal to 1 minus the probability of E. So the complement is everything outside of E. So if everything totals up to be 1, and we take out E, what's left is 1 minus that E. So that's where we're looking at that. So we can kind of look at this diagram here. If this is E, and the whole square is 1, this is going to be the outside of the circle inside the square is going to be this 1 minus that circle of E. We can also, if we just move things from side to side, we can say that if we take the complement out of 1, we're left with E, or the probability of E. And if we take the probability of E plus the probability of the complement, then we're looking equal to 1. So remember, the probability of an outcome in a sample space is a number between 0 and 1. So 1 minus whatever is going to be equal to the probability of the event. And then again, there's our sample space. So that means all the probabilities are going to total up to be 1. So the probabilities and warranties. If the probability that your CD player breaks down before the extended warranty expires is 0.025, what is the probability that the player will not break down before the warranty expires? So we're going to look at example 1, and we're doing part A. So remember, the whole thing will add up to 1. So we're looking at 1 minus that 0.025. So let's clarify here. So if the probability that it breaks down before the warranty expires is this, the probability that the player won't break down is 1 minus that probability. So if we subtract that out, we end up with 0.975. All right, let's look at B. So if there is a 1 in 5 chance that it will rain on your Memorial Day picnic, what is the probability that it won't rain? Well, it's going to be 1 minus 1 out of 5, because there's a 1 in 5 chance, so that's 1 over 5. I need to make it common denominators to subtract the fractions, so 1 will look like 5 over 5, minus 1 over 5 will get us 4 out of 5. So there's a 4 out of 5 chance that it won't rain. Part C says if 2 dice are rolled, find the probability that neither dice shows a 5. Well, we have to first figure out what's the probability of rolling a 5. Well, the probability of rolling a 5 out of a 6-sided dice is 1 out of 6, right? So it wouldn't matter what this number is. If it was neither die shows a 4, it's still going to be 1 out of 6. Whichever number you pick, because there's 6 sides to a dice, it's always going to be 1 out of that 6 there. So we're looking at 1 minus 1 out of 6 will end up getting us 5 out of 6. That's for 1 dice, right? Now we were talking about if 2 dice are rolled. So if we've got 2 dice that are rolled, so this is for 1 die, the chance of not getting a 5 is 5 out of 6. For 2 die, we have to take 5 6 times 5 6, and it'll be 25 out of 36. So you have to have the probability of not getting a 5 at all, and then on 1 die, and then multiply it by itself to get the 2 die. All right, so when computing the probability of the union of 2 events, it is a common mistake to simply add the probabilities of the 2 events because some outcomes may be in both events. So you must subtract the intersection of the events. So to find the union, we have to take out the overlap. So the rule for that, for computing that probability, is going to be if you have two events, E and F, then the probability of the union will be adding the probability of E plus the probability of F minus that little intersection in between. If E and F have no outcomes in common, they are called mutually exclusive events. And in that case, because the intersection is the empty set, the formula will simplify. We're not really looking at that. We're just going to subtract out what they have in common. So we're going to find the probability of the union of two events. Select a single card from a standard 52-card deck. What is the probability we draw a heart or a face card? So over here we have all of the hearts, and here we have all of the face cards. Now, in the middle where they overlap, these are the face cards that are hearts. So this is the Jack, Queen, and King of hearts right here. So let's go find our probability. So this will be example 2. And we're looking at the hearts. So if we're looking at H for our hearts, there are how many heart cards in the deck? Remember, we had 4 suits. We have diamonds and hearts and spades and clubs, and each suit has 13 cards, 1 through 10, and the 1 is known as the ace, and then Jack, Queen, King. So there are 13 hearts in the deck. Now we're going to use F to equal face cards. So for each of the suits, there are 3 face cards. There's a Jack, a Queen, and a King. And there are 4 suits. So if we take 3 times 4, we are going to get 12. So there will be 12 face cards. Alrighty. So now, remember that there's 3 cards that overlap. There's the 3 face cards that are hearts. So there are 3 cards that are both heart and a face card. So we're going to use that formula that we had on our handout here, but instead of E and F, we're going to have H and F. So the probability of the heart union with the face cards would be equal to the probability of the heart plus the probability of the face cards minus the probability of the heart intersected with the face cards. Now, we know what each value is, but what is the total number of cards we have? Because that's the total of the event. So remember, there's always 52 cards in a deck. So this will be equal to 13 hearts out of 52 plus 12 face cards out of 52 minus the 3 cards that are face cards and hearts, so they don't count twice. And we're adding like fractions. So over here we'll have 52. We have 13 plus 12 is 25. Minus 3 will get us 22. And this will reduce by 2's because they're both even, so we'll end up with 11 out of 26. So that is the probability of the union of hearts and face cards. All right, let's go to example 3. We want to find the missing probability. So a magazine conducted a survey of readers aged 18 to 25 regarding their health concerns. The editors will use this information to choose topics relevant to their readers. The survey found that 35% of the readers were concerned with improving their cardiovascular fitness, 55% wanted to lose weight, Also, the survey found that 70% were concerned or are concerned with either improving their cardiovascular fitness or losing weight. If the editors randomly select one of those surveyed to profile in a feature article, what is the probability that the person is concerned with both improving cardiovascular fitness and losing weight? So we are looking at the cardiovascular and their weight and where they intersect. So they're looking for that. And remember, we have to worry about it being counted twice. All right, so here comes example 3. So we're going to use C to equal the cardio. And it said in there that there was 35% of our readers were concerned with improving their cardiovascular fitness. We need to change this from a percent to a number, so we'll change it to a decimal by moving it 2 places to the left and get 0.35. Now for the weight, we'll use the letter W, and we had 55% of the readers were concerned with weight, so that's 0.55. And then we look at both concerned with cardio and the weight. They're looking at both. And yeah, or in the whole group. So let's look at that again. The survey found that 70% are concerned with either improving their cardiovascular fitness or losing weight. So it's not both of them because that would be the intersection, but both all together. So the union of those two, and that was 70%. And then we're going to change that to a decimal as well, so it'll be 0.70. And you can put the 0 in front or not. I don't care either way. Some people like it, so it makes it more obvious that it is that decimal sitting there. So we've got the probability of cardio union with weight is equal to the probability of cardio plus the probability of the weight minus the probability of cardio intersected with weight. So let's see what we know. We know the probability of the cardio was 0.35. The probability of the weight was 0.55. We weren't told what the intersection was, but we were actually given the union. The union where they were concerned with either one of them, which would be the union, would be 0.70. So that is going to go on this side. And then we're still subtracting the probability of the intersection. So this is what we're looking for this time. So let's go ahead and combine like terms here. We've got 0.70. When we add 0.35 plus 0.55, we will actually get 0.90 minus your probability of the cardio intersected with the weight. So now we've got to move things to one side. So minus 0.90. And that'll get us a negative 0.20 is equal to a negative, don't forget your negative there, of the probability of C intersected with W. Now I need to make this positive, so I'm going to divide by -1 on both sides. So 0.20 is going to be equal to the probability of cardio intersected with weight. So we end up with this is equal to that, but now we need to find the percentage. So we are going to state that because it equals 0.20, that then it's going to equal 20%, because we'll move it 2 decimal places to the right. So there's a 20% chance that if they randomly draw, that somebody will be interested in both. All right, let's go look at example 4. So a survey of 1,600 customers comparing the amount of time they spend shopping on the internet per month with their annual income produce the results in the table. If we select a consumer randomly, what is the probability that the consumer neither shops on the internet or more, let me see what that number should be because it looks like 0. Hang on. The consumer neither shops on the internet and we'll see how it goes here, or more hours per month, nor has an annual income, the internet 0 or more hours per month, nor has an annual income above 60,000. Sorry, I read it a little bit off. I think it's supposed to be 10 or more hours per month. We'll see what the data here is we're going to find. All right, so we're looking for above, and it is. This should be a 10 or more hours. So this should be a 10. I'm like, what number are we looking for? So 10 or more hours. So let's look at it again. We're looking, select a consumer randomly. What is the probability that the consumer neither shops on the internet 10 or more hours per month, nor has an annual income of 60,000? Sometimes those nors can be a little like, what are we talking about here? So let's go figure out what we're looking at. We've got 10 or plus hours, and we've got 60,000 kind of running right there. So if we're looking into this, we are, we've got, the survey is of 1,600 people, so let's kind of get an idea of what we're looking at. So we have 1,600 is what their total is that they're looking at, and it's in a table. We want to find the complement of the probability of 10 hours unioned with their annual income of 60,000. So the reason we're finding the complement is because we're looking, again, we talked about the negatives up here. If we select consumer randomly, what is the probability that the customer neither shops on the internet 10 or more hours, nor has an annual income above 60,000? So if we want the things outside of that, then we're looking for that complement. All right, so if we look at N of T, that's the number of the 10 plus hours. We're looking at 10 plus hours. If we look at 10 plus hours, we can see it's 192, 160, and 128. Those are all getting added together, and it's added for you in the chart, but I want you to understand where the values are coming from. And if we add those all together, we're going to get 480. Now, if we look at the probability, let's see, let's back up 1 second. The number in our sample is going to be 1,600. That's the total, the N of S. That's our total of the sample. We were told this up here, and we can see that the totals of everything add up to 1,600. And we can sample it, we should be able to sample this way and that way, and they both end up with that same total. Now, if we want to find the probability of the 10, it's going to be the N of T over the N of S. So the number of T over the number of your sample. And T is standing for the 10 plus hours. So that's going to be 480 over 1,600, which will be 0.30. Now if we want to look at the 60,000 income, we're going to call that the N of A for the annual income. And that we're going to find, if we look over here, 60,000, it's 192, 176, 128. It totals to 496. So again, I want you to physically see, so it's 192, 176, and 128 equals 496. So I'm trying to make sure you understand what's happening and where they're getting those totals. Because if you just look at it, sometimes it's not as clear. They added this row to get here, and they added this column to get the total there. So if we're looking at our probability of A, it's going to be the number of A over the number in our sample. So we've got 496 divided by 1600, and that'll get us 0.31. So we have our P of T, we have our P of A. Now what we need is the intersection. So the intersection of our T intersected with A, we can pull right from the chart. So here is our 10 hours, here's our 60,000, so that's where it overlaps, right there, and it's 192. So if we want to find the probability of T intersected with A, we take our 192, and we're going to divide it by that 1600, and that'll get us 0.12. So we've got our 0.30, our 0.31, and our 0.12. So if we want to find that complement, we're going to have the probability of T union with A complemented, which is equal to 1 minus the probability of T union with A, which is equal to 1 minus the probability of T plus the probability of A minus the probability of T intersected with A. So this will be equal to 1 minus 0.30 plus 0.31 minus 0.12. And we have those values from the three values that we found. So we're just really taking 1 minus all of those to find our answer. So we've got 1 minus, if I add those together, I get 0.49. So it'll be 0.51 when I subtract it, and that would be equal to 51%. So we do all this math, what were we looking for again? We were looking for what if they weren't using 10 hours and they weren't earning 60,000, it's going to be 51%.